This question says that Mars has an orbital radius of 1.52 AU, and it's asking for the period. What we know and what we calculated on the last slide is that we know that Kepler's constant for anything that is orbiting the Sun is going to be right here. So it's 1a squared per AU cubed. And what that means is we have 1 year squared per astronomical unit cubed. Remember that AU is the mean distance between the Earth and the Sun. So based on Kepler's third law, what we know is that the ratio of a planet's orbital period squared to its orbital radius cubed is going to be equal to a constant, which is Kepler's constant, k. We can rearrange this formula to say that we know that t squared is going to be equal to our constant times r cubed, which means we can say that t is going to be equal to the square root of k times r cubed. Now we can put in our numbers and solve. So here what I've put in is we have Kepler's constant for anything orbiting the Sun multiplied by our radius cubed, and that will get us an answer of 1.87 A. And remember that A is the symbol for year. This question is asking about Mars's two moons, Deimos and Phobos. We know that what we're looking for is the radius of Deimos. Based on Kepler's third law, we know that what I've written here on the right, we know that the ratio of a planet's orbital period squared to divided by its orbital radius cubed will be constant, and that's what k is. That's our Kepler's constant. Both of these moons are orbiting Mars, and we don't know the Kepler's constant of Mars, but since both ratios have to equal our k, we can set them up equal to each other. So what we can say here is that the period of Phobos divided by the radius is going to be equal to the same for Deimos. Now that we have our formula, we can rearrange and solve. So what we're looking for is our RD3, so we need to get it on one side all by itself. So here's my formula, RD cubed equals TD squared multiplied by RP cubed divided by TP squared. Now I can substitute in my numbers and solve. So I've subbed in my numbers here, and what's happening is the days on the top and the days on the bottom are canceling out. If I do the math here, I'm going to get 1.29 times 10 to the 13 kilometers cubed, but I need to take the cubed root in order to get my RD, which is what I'm looking for. Once I take the cubed root, what I get is that I have 23462.8 kilometers. In order to put it into significant digits, I have 2.346 times 10 to the 4 kilometers.